Good afternoon, this is Kavi Priya, Assistant Professor EC Department, SNS College of Technology. I am going to discuss about plane waves in good conductor. So this is my flow of presentation. I am going to give a short introduction about the good conductors and what is a Maxwell equation in good conductor and how this wave equation is obtained from Maxwell equation, and about the propagation constant gamma, what is the concept behind the skin depth and intrinsic impedance, and finally the applications. First, what is a good conductor? So, any material which has the conductivity sigma greater than omega epsilon, the particular material is a good conductor. Examples for this good conductor are aluminum, copper, etc. So, in case of good conductor, the conduction current will be dominating the displacement current. And next one is the Maxwell equation for good conductor. It is represented as del cross E, del cross H, which contains a term E and H, where E is electric field intensity, H is a magnetic field intensity, sigma is a conductivity. So it contains the conduction current terms. And how to obtain this wave equation? So after substitution and simplification of this Maxwell equation, we'll be getting a wave equation. It is represented as del square E, which contains mu sigma dou E by dou T plus mu epsilon dou square E by dou T square, where sigma is a conductivity and mu is a permeability and epsilon is a permittivity. Next one is the propagation constant. So the propagation constant is represented as gamma. Gamma is equal to alpha plus j beta. This is a generalized expression where alpha is a attenuation constant and beta is a phase constant. So whenever the wave travels across a medium, there will be a decrease in the amplitude of the wave. So the decrease in amplitude of the wave, we will be calling it as an attenuation. So this decrease in amplitude of the wave is given by the attenuation constant. And whenever the wave travels across a medium, there will be a change in the phase of the wave. There will be a change in the angle of orientation of the wave. That is given by the angle phase constant. So alpha is an attenuation constant and beta is a phase constant. For good conductor, this alpha is approximately equal to the beta. So we have this alpha and beta equation are similar. Alpha is equal to square root of pi of mu sigma and beta takes the same equation, square root of pi of mu sigma, where f is a frequency, mu is a permeability and sigma is a conductivity. So the wave will be decreasing exponentially. So the decrease is given by this attenuation constant. So there will be a skin effect observed in the waves. And next one is a skin depth. So skin depth is nothing but the wave will be decreases to the 37% of its original, and this process we call it as a skin effect. So skin depth is given by the notation del. Del is equal to 1 by alpha, which is nothing but 1 by square root of 2 divided by omega mu sigma. It can be a 1 by beta as well. So this skin depth is an important concept in high frequency circuits. And next one is the intrinsic impedance. Intrinsic impedance is nothing but it is a ratio of magnitude of electric field to the magnitude of the magnetic field. So this is one which indicates what is a phase difference occurs between the E and H, electric field intensity and magnetic field intensity. So it is a complex impedance. So in case of the good conductor, this eta, which is nothing but it is an intrinsic impedance, is approximately equal to 1 plus j divided by square root of mu omega mu by 2 sigma, where j is a complex term. And next one is the applications of this good conductor. So it is being involved in the transmission lines. So it is efficient in electrical signal transfer in RF and microwave systems. This is the first foremost application, and it is being used in the waveguides. So guided electromagnetic waves in RF microwave and applications. So the wave will be applied in this RF and microwave applications. Next one is a shielding effectiveness. So it is one which minimizes the interferences and it ensures the signal integrity and signal quality. So shielding effectiveness is being involved in over here. And finally about the RF and microwave system. So this electromagnetic waves is predominantly employed in the communication systems as well. So far, we have discussed about what is the good conductor, what is the condition for good conductor, and we have discussed about the Maxwell equation, and we have discussed about the wave equation, and about the propagation constant gamma, alpha plus j beta, and we have discussed about the intrinsic impedance and cover the skin depth as well, and finally about the applications as well. These are all my references. Thank you all.